All right, I think the right side is a little cropped, but hopefully it's not going to be a big of a deal. All right. There was a time where there was no web. Tim Berners-Lee, a scientist at CERN, a large research institution in Geneva, came up with the idea in 1989 to have a system of documents that will connect them to make sense of what is actually being written in the documents. The original schema is very simple. Documents are texts, and texts are linked with hyperlinks to other documents, and so on and so forth. In the year 2017, we can play with this, if you believe that, and I will show you how using apple.com. Connect to the port 80, apple.com. After the initial TCP handshake, we're going to ask for the document at the root of the server, and the server starts to respond with the document content. And at the end of the document, the server goes away because, well, there's nothing else to do. There was one document, and the content will tell you how the request actually went. Okay? There was no 404 and so on. At the beginning of the 1990s, there was a protocol that was more prevalent, and that was called Gopher. If you're old enough to remember, it's an interesting topic why Gopher died and HTTP succeeded, but that's a talk for another story. All right, the vendors started extending this HTTP simple implementation, and they started adding more and more. They wanted to add images, audio, style sheets, and things like that. And we end up with HTTP 1.0 in 1996 and 1999, we had HTTP 1.1. So what are HTTP 1.1? That's a little mouthful. When I say HTTP, I mean 1.1. All right, so in a typical situation, it goes like this. Here we have two timelines. Left on the left side, I have a laptop because that's a client. On the right-hand side, we have a iMac because I don't have the emoji for server. The time goes from top to bottom, and the data flows between them. All right. First, we will establish the TCP handshake. You know this, SYN, SYNAC, ACK. And after that, the client starts asking for the documents. If I say get index HTML, the server will respond. And as the client reads the document, it realizes that it needs more resources. For example, we want style.css, app.js, and so on. The server will do the work and return the documents as they are queued. All right, that's pretty simple, hope. We can do this with Telnet again in the year 2017, and we have initial TCP handshake. We get the HTTP request followed by one or more headers because host is a required header. It will be followed by, two pairs of carriage return line feeds, and the server will return with a status line, the headers, followed by two pairs of carriage return line feed, and the document. And at the end of the document, if you're following along at home, you will notice that the TCP connection is kept alive. If you want to ask for more resources, you can do that following the same rule, the document request, the header, and so on. All right, so what are these things? The characteristics of HTTP is interesting because it will tell you why we do certain optimizations. For example, we have plain text headers, which are very easy to read for humans. And we will reuse the TCP connection because it will save you some time about doing the initial TCP handshake. If you don't have to do that over and over and over, doing the same thing, you will gain performance, right? And one important characteristic of HTTP is that requests are queued on the server in the order they are received. Okay? So you want to make sure that the critical things that you want to render the page are requested first. Okay? Things that take longer, you want to do that later so that you don't have to force the users to wait. Another thing is that session data are stored, transmitted on each request. Remember, the original implementation was just one document. You want one document, and the server will respond with one document and one document only. There was no state involved, and HTTP 1.1 will have to pay for that. Another thing is that browsers will enforce certain rule about the number of connections you can have on the client side. This will force us to do certain optimizations that we might get into later. So what is HTTP2? HTTP2 is a very long word to say for me, so I'm going to just shorten it to H2. Okay, H2. All right. It's a new protocol based on experimental protocol named Speedy, which came out of Google back in 2009. And it became more or less the springboard to HTTP2, which is published in 2015, and you can use it today as the standard. All right, so what does it look like? Here we have the same timeline, server on the right, client on the left. We have TCP handshake, and then after that, we will have TLS, transport layer security handshake, that will tell you what protocol to use. And after the TLS handshake, the application data will start to flow. TLS is not strictly required for H2, but many vendors, including Chrome, Firefox, Safari, and Opera, I believe, they all require TLS because it will allow you to do this thing called application layer protocol negotiation, which means that this client will request the H2 if you can, if the server can, and if it's not possible, it will downgrade to HTTP to continue with the client session. All right. What are good things about HTTP H2? All right, H2. First of all, we have binary headers. Humans probably cannot read this anymore, so I don't give you the telnet session here. But binary headers are compact, and it will save you the amount of time that you have to communicate with the server. And you can also compress headers very well with another RFC named HPAC. This will also allow you to do some reuse on the headers so that you don't have to transmit cookies and session IDs all the time. If some things are omitted, certain things are assumed. And there are rules that these things can happen. As an application developers, you probably don't have to worry about them, but this is one big advantage for H2. Another thing is multiple full duplex connections, which means that for each request, the server and client can talk independently. You don't have to be blocked by other resources that will take a long time to process on the server, for example, so that you can be a little more lax in certain aspects of your programming. There's one more feature on H2 on the server side, namely server pushes. Servers can push resources according to some basic rules, like if you ask for this style sheet, the server will push to the client other, let's say, fonts or images or things like that without a client telling it to. If the client accepts it, that will save time on the client side to decide whether or not the client wants that resource. It can be wasteful because the rules might be suboptimal, but it could potentially be a performance boost. All right, so these are the basic features of H2, and let's take a look at what the tooling look like right now. Okay. As I mentioned earlier, browsers are more or less compliant. Many major browsers will require TLS, but supports H2 as a result. I don't think you can read the chart on the right, but the only red thing that you see is Opera Mini. Who uses Opera Mini? Okay, so I guess we don't have to worry about that too much. And if you're using a Chrome, you can look at this. If any of your sessions in the browser is alive with H2, you can look at what they are. You can look at the number of connections, number of sites, and so on and so forth. All right, so browsers are okay. It's doing a very nice job of supporting H2. But what about the CLI tools? My CLI tool of choice when it comes to HTTP and all the other things like, I don't know, FTP and things like that is curl. And it turns out that it's not particularly friendly just yet. Okay, what happened here? Nope. The computer is alive. Okay, let's see. This is not, okay. Let's see. Ooh, okay, so H2 support is not very readily available for many OSs. Oh, that's me. Oh, I have stickers. That one. I can't sing, so I have to call Liam on the stage. What's happening? Okay. So let's see. Curl's H2 support is not readily available on many OSs. That means no on Ubuntu out of the box, no on OS 10 up to El Capitan, because I have not tested Sierra. If you can test that for me, I guess. Ah, yes. All right, so yes, so right, where are we? Right, H2 support on curl. Yes, on Fedora. If you pass this flag dash capital V, you will get this long list of features that are implemented for this executable. And in the last line, you notice HTTP2. Okay, for Fedora, it is great. On Ubuntu, it is not, because you can see the last line features doesn't have HTTP2 written there. And the same goes for El Capitan, as I mentioned. So if you want the H2 support, you need to do some compiling, and that's pretty straightforward, it turns out. On Ubuntu, you get the ng-http2 package, new generation of HTTP2, which means HTTP3, but it is not. You can configure it from source and just do it. Same with the Mac. If you're using Homebrew like I am, you will install ng-http2 and pass this long configure parameter. Don't worry about that. You don't have to take notes because I have a link of links at the end of the slideshow. So you don't have to worry about that now. If you run it with a capital -V, you will notice that HTTP2 is available. All right, so how does that look? You're going to do the Google because Apple doesn't support H2 yet. If you pass the little v, you will notice that at the end of this line, in the middle, you will see ALPN offering H2, application layer protocol negotiation. Client will ask the server if we can do H2 first, and then if it's not, I'm going to do HTTP 1.1 as well. And in the next screen, the server will respond and says, yes, I am going to do H2, second line. And then at the bottom, you will see that from the server side, H2 response comes back. 302 is redirect, and you shouldn't do that, but I'm going to talk about that later. Okay. All right. So what as Ruby developers can you do to make things better for H2? Remember, there are some good practices that you should be doing right now, which is great for not just H2, but for HTTP 1.1. First, you want to put assets on the content delivery network. There are many inexpensive solutions these days. You don't have to use Akamai anymore. And if the assets like images and style sheets are closer to the user, physically, you have better shot at good performant web application. You still want to reduce DNS lookups because those are very expensive. And you do not want to redirect HTTP requests because those are basically wasted bandwidth. You do work and then you realize, well, you should ask this server after all. That's a lot of waste. If you can avoid it, don't do it. All right, but there are some changes to the rules with H2. So what are they? Well, first of all, you want to figure out if you can use it at all. Some application platforms do not have that support yet, namely Heroku. I have been told, I have asked, because that's very important to me, and they are working on it, but still not there yet. And you want to split assets, probably, with some qualifications, because if the assets are small and do not change often, those assets can be cached on the server and they can be served faster, right? But if the assets are too small and they change too frequently, maybe your win is not as big. You don't have to shard domains anymore because the connections from the client to the server is fully duplex, and there is no limit to the number of connections you can make. And finally, you want to test different servers. There are many H2 implementations right now. None of them does not seem to have a stronghold in terms of H2 documentation, implementation and performance. There are important ones like H2O, which is currently supported by Fastly. Nginx has a support for H2 now. Tomcat, Apache, all of those things will support H2. All right, now where does it leave us Ruby developers? What does Ruby H2 server code look like? When it comes to HTTP, it's either Rails or Sinatra with some nod to Dry RB and Hanami, but they are mostly written on top of Rack. Rack has this very simple promise about what data structure you are passing around. It's a triple of status code, header hash, and response body. Okay? This is very simple, and it helped standardize many of the application server code, but it's not very friendly to H2 because this assumes that there is a complete response, request and response cycle that H2 does not really consider. So some work needs to be done on Rack, and I know that Aaron Patterson did some work for proof of concept a couple of years ago. It's not there in the main line yet, so we need some work there if we want to get Sinatra and Rails to H2 in a reasonable time. But there are things you can do right now, and namely proxying to the H2 server up front. All right? And this might be okay, good enough for the performance that you want right now. All right, what about the client code? There are two Ruby implementations of H2. One is called HTTP2, written in pure Ruby by Ilya Grigorik. And Tenderlove, aka Aaron Patterson, has a wrapper on NG HTTP2 called DS9. That's a Star Trek joke. Neither of these things will downgrade to HTTP 1.1 if H2 is not available. So you need to have some fallback logic to do things if that is important to your client code. All right, time is coming up, so let's recap. We have looked at the features of HTTP 1.1 and H2 and compare how that will affect our decisions on application code. By playing to H2's strength, we can get started on the journey to H2 performance going forward that is not in the too distant future. All right, that's it. And here is the list of links that you can take a look at. What do I have? Yes, curl configure options and other server implementations and things like that. As I said before, I have stickers. Oh, I don't have them with me. It's in the bag. But if you want them, just come find me after the talk. Thank you.